Okay, hello everyone, and today instead we will be looking at how to create z-scores in Jamovi, how to create a composite z-score in Jamovi, and then we will check how to create box plots and how to interpret them. So let's first paste the data that we will need in order to have a tutorial about z-scores. I will just paste the IQ scores from three different scales. We have the first one being the IQ from the Wechsler Adult Intelligence Scales. The second one is the IQ from Cattell. And finally, the third one will be the IQ score from the Stanford Binet. Remember, as these variables are scores, we want them to have continuous as a measure type in Jamovi. Remember, here is where you can change it from. Now, since we talked about the importance of z-scores in the past, it's important to know how to do them in Jamovi, right? So, first of all, let's select all our variables in as much as we want to transform all of them into z-scores. If we want to transform only one, of course we'll pick only one. But in this case, we want to transform all three variables. Then, Jamovi usually puts us into the Analysis tab. Instead, this time we have to go to the Data tab. And to transform these variables into z-scores, guess what? We'll have to click on Transform. Now, if here we had created already a transform, we would have here some transform. However, since we did not create it yet, and you have to create it in each new dataset, we have to simply click on Create New Transform. Now, here is simply the name of the transformation. You can keep this, you can put whatever you want, however, for simplicity and let's say to just, be a bit more rational, we will call it as we are transforming the same thing. So like, if we're transforming it into a standard score, we'll call it standard score, z-score, and so on and so forth. Why? Because it will help us then recognize which of these variables is the one which we already transformed. Now, when you click on the transform function in Jamovi gives you by default this writing here, which is $source. $source simply tells the system, tells Jamovi, that what we're transforming here is the source. So in this case, these three variables that we had here in the beginning, because these are the source of our transformations here. Now, in order to transform this into z-scores, what we have to do is to click here on the F, which is the functions, and we will find, by scrolling down, z. Now, we want to put this, not one click. If we have one click, it just simply tells us how it works, right? Like in Excel. So in order to put it here in this string of text, we need to double click it. And as you see, we double click it and appears a z and two parentheses. Now, in this case, we want to have this $source be between the two parentheses. So we will just remove the closing parentheses and create it again here at the end so that the $source will be inside of the parentheses. And now we click outside and we have our transformed variables. So looking at this, you can see that we have created the z-scores for each of these IQ scores. Of course, for each participant, remember the IQ we will have here, the z-score we will have here is the transformation of what we had here. The z-score we have here, the same. So just keep in mind this. Now, keep in mind also the z-scores, they will have quite low numbers because this is just re-expressing this score in terms of standard deviations. When they have no sign, it means plus. When they have a minus, it means minus. So in this case, participant 1, it had 2.2 if we approximated standard deviations as a score. Here it had minus 0.2 or 0.3 standard deviations, and here it had minus 1.7 standard deviations. So just for you to keep in mind what a z-score is, just that's it. But again, Jamovi will simply transform it for you. Now, after we created these z-scores, we want to see, among these people, so these participants, it's in total of 100 participants, who has the highest composite z-score, of highest composite IQ. Because as you can see, for instance, this participant over here had a pretty high vice IQ, but it had a quite lower, or below the mean, Cattell and Stanford Binet. So of course we want to check by giving to all these people 3 different IQs who has the highest in total. So we cannot simply sum these numbers because it would not give us something very reliable, because they have 3 different types of measurement, and that's why we use z-scores. So we create now a composite z-score. A composite z-score simply means that we are summing up the z-scores. So in order to do this, we click here on add, because we want to add a new variable where we're doing some mathematical operations. So we pick on the computed variable. Why? If we will click on data variable, it would simply tell us that this is just like, a new variable, like one of these, like something that usually we just paste from Excel. Instead, a computed variable is a variable in which we can do some mathematical operations, like summing them up. Transform variable instead is what we did before with z, so like we're just doing something like, a bit more complicated. We're using some function, like can be like the z transform, and it will be always referred to an original variable. Whereas for computed variable, it's like a new variable, there is no reference to any previous variable, but we can just do some mathematical operations. But either way, we just click on append, which will make us have the variable in the rightmost part. Instead, if we would click on insert, it would just insert it somewhere here, but for the sake of this video, we just click on append, just the easiest to know where they are. And as you can see, you will have a new variable. Now, you have to do something about it, right? So you just double click as usual in order to activate it. You will call it, in this case, composite IQ, because that's what we're going to do. And then we click on the functions. So again, this time, since we want to create a sum of all the IQs, we have to find the sum function. So we scroll down until we find sum. Again, not only one click, but double click. We double click into it, and then we have to put the variables we want to sum. So in this case, what we want to sum is our transformed z's, and that's why I told you to rename it into something that makes sense, because otherwise here you will have something like IQ vice transform 1, which, yes, understandable enough because that's the only thing you did, but like just imagine if you're transforming more stuff, right? So anyway, we want to have these variables, and so we double click them again, not simple click, double click, and you will have this inside. You can see you have these quotation marks because we're telling Jamovi that this is the name of a variable, but it will do it automatically. Then we want to put a comma because we want to separate this sum variable from this other sum variable, for instance. So we need to separate them with a comma. Telling Jamovi we want to sum this plus this and plus this. So keep in mind you need to have these commas over here. And like again, in case you see, Jamovi will just tell you put a comma. Then we click outside, and as you can see, Jamovi will have summed these 3 ZIQ. So as you can see, this score here is the composite IQ score for participant number 1. This one is the same for participant number 13. So now from this we can check which of these scores is the highest and which is the lowest. How do we do that? Well, we will have to go back to our descriptive statistics in order to double check this. Simple as that. We go to exploration, descriptives, as you might already know, and we just put composite IQ. Jamovi will give us by default the minimum and maximum, which will make us say that the highest composite IQ, Z transformed, is 5.89, which is definitely way above any mean, because it's 5.89 standard deviations above the mean, whereas the minimum is minus 4.44. If you guys are curious, you can also see who of these participants has it. So if you would go on statistics over here, you can click here on the outliers, and Jamovi will tell you the participant that have the most extreme scores, from highest or lowest. So we know that the person that had a 5.89 composite IQ is participant in row number 5. So we will check and we will see, yes, it's exactly like that. Of course, keep in mind that sometimes Jamovi is approximating to 2 decimals, so don't worry if the numbers are different. whereas the lowest, the person who scored minus 4.44, is row number 26, and yes, it is minus 4.437. So yes, in this case, if you guys want, you can check who has these scores, but most of the time you will not need it. Now that you guys know how to do z-scores and how to create a composite z-score, now we will look at box plots, how to create box plots in Jamovi and how to interpret them. So now that we will paste some other data, this is just gonna be about age of participants. So again, keep in mind age is a continuous score, so it's a continuous variable, so be sure to change that. And now we will go to our exploration, because keep in mind that, as you should remember from last video, when we want to do plots, we always find them in descriptives over here, as you can see. Now, we want to create it for this variable over here, so we just add it over here. Now, we simply go to plots, and as you can see here, we have box plots. We just click here, simple as that, and we will have a box plot which will tell us how our data are mostly distributed. Now, in order for me to comment a bit more on this and talk about the 6 numbers rule when it comes to box plot, let me add some other elements here to the descriptive so that you guys can see. Let me remove the missing and the number just because we don't need it right now. Let me remove the mean because we will not need it right now. Let's put percentiles instead. So what we're gonna see right now is how this box plot can actually mirror what we have in descriptive. So sometimes you might want to have a figure instead of a table, or you might be asked to do this in a test or in a midterm or something of the sort, right? So 6 numbers rules. The 6 numbers we're looking for here is the 1, is the 2nd, is the 3rd, 4th, 5th, and 6th. Now I will explain them one by one. So the first number is the lowest point of the box plot, or the whisker of the box plot, and this number here, number 1, represents the minimum score on our variable. So as you can see from the descriptive, the minimum here is 19, and as you can see from the box plot, you can check how it's going on the y-axis, the h-axis, that it's kinda 19. Yes, so remember, number 1 is the minimum. Number 2 instead is where the whisker is conjoined with the box. And this number here is the first quartile, or as you might know, the 25th percentile of our variable. In the descriptive table over here, the 25th percentile equates to 22, and as you can see here from the box plot, it is indeed 22. The third number instead, one of the most important, is the median. Keep in mind, median also known as the 50th percentile. So, as you can see, 31, 31. That's how it goes. So, as you can see also from the box plot, if we will trace a line, it will get to 31. So, third number, median, or the second quartile or 50th percentile, they are synonyms. The fourth number instead, or the upper edge of the box, is the 75th percentile, or the third quartile. And as you can see, in the descriptive table is 34.3, and here we will have also something like 34.3. So, the fourth number is the 75th percentile. The fifth number instead is the maximum. Now, here is where things are a bit more complicated, because if you remember from your statistics classes, the problem with the range meaning the minimum and the maximum is that it is very sensitive to outliers. So the real maximum in our age is probably not 60. We just have someone, participant number 14, as you can see the box plot tells us already, who is 60. So this person is an outlier. Just by looking at the numbers here, you see that majority of them are like in their 30s, someone is in their 40s. If you guys want to double check it, you can also, just put the standard deviation here, and you will see that like majority of the participants will be between plus minus 1 standard deviations from the mean being 29.2. So you will know the majority of participants will be something like, from early 20s to maximum like, late 30s. Majority of them, not everyone, of course. So this 60 here, which the descriptive table tells us is the maximum, it's a false maximum, or rather, it is the actual maximum, but it's just like an outlier. So we would see here from the box plot instead that the maximum is somewhere around 41 probably. So remember, the fifth number is the real maximum. So it's a maximum which is not really subjected to outliers. Number 6 instead is the outlier. So the individual or individuals which are scoring significantly higher than the rest of the participants in your dataset, in your study, or on your variable. So in this case, we know that participant number 14, because Jamovi is so kind to tell us, is the outlier by scoring 60. So we will go again to row number 14 and we see that yes, this person is indeed scoring 60. This was all. Hope everything is clear, and if not, feel free to drop a comment, and good luck with everything.